We are going to be looking at 3.1, the complex numbers. We are going to just perform basic operations of complex numbers, adding, subtracting, multiplying, and dividing. And most of these operations are things that we are familiar with. The new concept is just bringing the I into different type of situations that we already are familiar with. Now, when we have radicals, we cannot have a negative inside of a square root or any radical that has an even index. And we are going to just look at square roots. So whenever you have a square root, you cannot have a negative inside of the radical. When you have an odd index, you can have a negative inside. So sometimes students get confused about that. They'll take out an I for an odd index, but we only take out I's when we have taken out an I when we have a square root. So if when I look at my rules, it states that whenever I have a negative, I take out an I. Whenever I have I squared is equal to -1. So the I only comes out when I have a radical, a square root. For example 1, I have the square root of -3. So the first thing I need to do is take out I. Now I separated it, but you don't have to separate it. You can just take out your I, pull it right out, and just write the radical. So I get I radical 3. The negative comes out, it becomes I, and you have radical 3, and then at that point, it's just old steps that we use to simplify radicals. Example 2, there's a negative that's already outside, so it stays negative. And then now I have I, and by taking out that I, my radical is positive. I have a +7 that's inside, and that's all I can do. So I have -I times radical 7, or the -I times the square root of 7. So there's nothing to break down, so it stays like that. Now, in the third example, I comes out. Now I have a positive radical. And now I just need to break down 75 to 25 times 3. And I can continue if I wanted to, but I know the square root of 25 is 5. But just in case I didn't know it, I can break it down for every two of the same numbers. I bring it out one time, so I get 5I radical 3. So it's just as simple as pi, that you just take out I whenever you have a negative in the square root. Any questions on removing the I from the square root or making the radical positive? Now we are going to add and subtract. And the thing about adding and subtracting, you add and subtract just like we do regular binomials. So we treat I just like we treat X or Y or Z, based on what variable that we have. So we treat it the same way. And the only difference is that when we write our final answer, it has to be written a certain way. So our real part, which is the A part of our A plus B, has to be written first. So that's your numbers without the I attached to it. So the real part has to be written first, which is just regular numbers. And then your imaginary part has to be written after a second. That's your B part has to be written after the A, or A, B. So they just have to be written real part, imaginary part. So this is the way we need to write it. So your real part is the A, and then plus BI, that's your imaginary part. So in example 4, we add in. So when you add, just like we add regular binomials, you just take away the parentheses. You see, we add in here. So you just take away, remove the parentheses. Do not multiply because that sign is in the middle here. So that means we are adding. So just remove the parentheses and then just combine like terms. So I'm going to do the real part of it first without the I's. I'm going to combine that. I have a -4 and a +6. I get +4. I mean 2. I'm tripping. I get +2. And then the last +7i plus 5i, I get +12i. So just remember that you have to just take away the parentheses and combine like terms just like any other type of binomials that we had in the past. In example 5, we do the same thing, but we always have to do that extra step when we are subtracting. So the first parentheses, you can just take everything out. You can bring everything out. 14 plus 9i. Now this negative here, it's like a -1, if you will. Multiply each term that's inside. So I get a -8. And then I get a -3i. So remember that you had to multiply a negative by each term that's in parentheses. And now at this point, I combine like terms. So 14 and -8 is 6. And then I have 9i and a -3i is 6i. My final answer is 6 plus 6i. And now I'm going to do another subtraction problem. People wrong. So the first step, I just write everything from the first parentheses right out. And then the second one, I have this negative here. So I need to multiply negative by each term that's inside. Negative times a -8 gives me a +8. Negative times a -8i gives me +8i. And now I just combine like terms. 8 and a -4 is a +4. Got it right this time. And then I have +3i and +8i, 11i. So everything is things that we already know. We already know how to add and subtract binomials, and we just do the same thing with complex numbers. We just get the i's together and we just write them at the end. So we just have to remember to write it in form a plus bi. That's really only the new concept. It just have to be in a certain order. So moving on. So we added and subtracted, so we know we're gonna multiply and divide because they are cousins. So we're gonna add and subtract. You know that we're gonna multiply and divide. Now in 7, at first you might think that since there's a negative in both radicals, that you would just multiply that and get a positive radical. That is not the case. We always have to take out the i's first. We always have to make our radical positive first. So I need to take out the i's first. And you can rewrite it in parentheses if you want, or you can just put the sign in the middle. So now the i's are out. And if I simplify the radicals first, it seems easier to do that. So I get 5. Square root of 25 is 5. And the i's are multiplying it by I. And then I get 5. Multiply 5 times the 4 first. Get 20. And then I times I is I squared. Now the rule states that I squared is -1. So whenever I multiply two i's together and get I squared, I'm going to change it to -1 now. 20 times -1, which is -20. I have the I, simplify the radicals, and multiply. I change the I squared to -1, and then so we know that we can do two things, either for you, use the for you property, or we can use the distributive property. But I'm a for you, and we for you just like we have done other binomials in the past. So I multiply my first numbers together. 5 times 3 is 15. Then my outer, I get -20i. And then my inner, I get +27i. And then the last, I have a +9i and a -4i. So I get -36i squared. So 9 has an I and 4 has an I. So when I multiply 9 and 4, I get 36. And then I times I is I squared. So I'm just going to combine. I'm going to bring down my 15. Combine my like terms that are in the middle. -20i and a +27i is +7i. And now my I squared, I change to -1. And when I change that, I get 15 plus 7i plus 36. So -36 and a -36 and the -1 gives me a +36. Now I can combine the 15 and the +36, which is 51. And then I just keep my 7. Final answer is 51 plus 7i. Now in the last example that's on this slide, we're still multiplying, so we just multiply everything in parentheses by -2i. -2i times a -3 is +6i. -2i times a +3i is -6i squared. -6i stays 6i. -6. Now I need to replace I squared with -1. -6i and -1 gives me a +6i. I mean a +6, excuse me. And then I need to switch it around. It has to be in a plus bi, so 6 comes first, plus 6i. So the final answer is 6 plus 6i. So we just need to rewrite it. So we are just doing the familiar operations with binomials. The only new concept that came into play is the I squared, that we need to replace that with -1. And that's the only thing that need to be replaced in problem 8 and 9. And in problem 7, we just took out I because of the negative. So those are the only two concepts that you really need to know for complex numbers. Well, two of the concepts. There's a third one that we are going to look at. In problem 10, I am going to multiply. In 11 and 12, I'm going to introduce the conjugate, a new concept. So just look at 10 first. So it's just written differently, just our binomial being squared. So we are just multiplying it by itself. So we rewrite it out twice. Exactly the same like is written. 4 plus 6i. So we just write that twice. And then you just FOIL. So you just want to FOIL. So 4 times 4 is 16. And then 6i and positive 4i. And then my inner, I have another 24i. And the last one, the last two numbers yields 36i squared. So don't forget to I multiply the i's. I times I is I squared. So I just need to fix it up a little bit. 16 stays 16. 24i and a 24i gives me 48i. Now this I squared changes to -1. So I have 16 plus 48i minus 36, or -36. And now I combine like terms. So the only thing I have that I can combine is the -36 and the +16, which is -20. And then I just bring down my 48i, my +48i. And my final answer is -20 plus 48i. So we just multiplied the two binomials. Well, you read out twice because it's one binomial being squared. So we read it twice and then just FOIL and get the final answer. So in the last two on this page, 11 and 12, we are introduced to the conjugate. Just like radicals, where we have radicals in our denominators, we didn't want them there. We cannot have radicals in denominators because, it's, we want to make sure that we always have fractions that are defined, and we need to always read radicals. So likewise, when we have complex numbers, when we have an I in our denominator, we also want to get rid of that. Now, in order to get rid of that, we multiply the expression by its conjugate, meaning that we take the same numbers, but we change the sign to the opposite. So we want to multiply the numerator and denominator by the same signs, but the opposite. By the same numbers, but the opposite signs. Multiply. So you want to multiply by the conjugate. So once we multiply by the conjugate, the i's are going to be removed, or I is going to be removed. So I'm going to start with the denominator. Now here, since we are multiplying by the conjugate, we don't have to do the entire FOIL method, because those inner numbers are going to cancel. The outer and the inner are going to cancel. Doesn't make sense to just do the whole process when they are going to be eliminated anyway. The only thing you really have to do is the first times the first, and then the last times the last. So the first time the first would give me 16. So the 4 gives me 16, and then I just multiply the last two terms. I get -81 squared. And now I just can get rid of that I squared by changing it to a -1. So -16 comes down, -81, and -1 is a +81 now. So I have 97 in my denominator. Now I'll go to the top and just multiply that out. So 8 times 4 is 32. 8 times positive 9i is 72i. Once I get here, there's nothing I can add at the top. There's no like terms or anything. But since I have this fraction, I need to separate it because I need for the real part to be independent and my imaginary part to be independent. So I need to separate them. So my real part is 32 over 97, and my imaginary is 72 over 97i. So we just need to separate our real part and imaginary part. And once I do that in this problem, I have 32 over 97 plus 72 over 97i. So any questions on 11? So again, we introduced the conjugate, meaning that in order to get rid of I in any denominator, we want to multiply it by the same terms, but we need to change that sign to the opposite. Now moving on to 12, the same, I need to get rid of the I in the denominator. So I just multiply by the opposite sign. So change the numbers the same, but change the sign. So when I work in the denominator, I get 4. 2 times 2 is 4. A positive 5i and a negative 5i is negative 25i squared. Now I just need to change I squared to negative 1. And when I do that, I have a negative 25 times a negative 1 gives me positive 25. Now I add 4 plus 25, I get 29. Now I just have to multiply the things in the numerator. So I multiply 5 times the quantity of 2 negative 5i. So 5 times 2 is 10. 5 times negative 5i is negative 25i. And that's all I can do with the numerator. And now I just need to separate my fraction. I need my real part to be first. And my imaginary part to be second. And this is the final answer. Now, if you have fractions that you can reduce, then you reduce them, but these cannot be reduced, so it stays 10 over 29 minus 25 over 29i. So any questions about finding the conjugate to eliminate the I from denominators?